Okay, are you able to see the slide here?
Yes, sir.
Yes, sir.
Okay. So आवाज
Yes,
भी
sir.
क्लियर आ रही है ना? वॉइस में कोई ब्रेक तो नहीं है ना?
No, no, sir.
Nice.
Okay. So let us complete the blood pressure today. Okay. So we had completed the introduction part and we had already started the blood pressure. And I think in the previous class I had explained you about the blood pressure, what is blood pressure and how the blood is getting pumped from the heart. And I also explained you the mechanism of the heart. And then I had explained you the analog type of sphygmomanometer, right? So let us today discuss the remaining part of our blood pressure, what is distal sphygmomanometer, what is distal sphygmomanometer, how it is going to work, and then uh, how the correction factor has been taken and other indirect method. These are the indirect methods, right? Whenever we are going to measure the blood pressure by using sphygmomanometer, this will be your indirect method. Okay. So once we complete the indirect method, so we also discuss the direct method. Okay. So we'll just go through the brief of the direct method because it is not that much important to study about the direct method, but I will give you the basic knowledge required for the direct method. Okay. So let us start today's session. Okay. So first of all, the blood pressure may be of three different types, right? So it may be your arterial blood pressure or venous blood pressure or capillary blood pressure. Right? That means on which blood vessel you are going to measure the blood pressure, right? And normally the sphygmomanometer or everyone uses to measure the first one itself. Okay, arterial blood pressure. Okay, so venous and capillary are some special conditions and they are very rarely measured. And most of the time, the doctors use it to measure by using arterial blood pressure. Okay, and then coming on to the how blood pressure is determined. Okay, so if you want to determine the blood pressure, okay, so how there is there any formula for determining the blood pressure? So as there is a formula. Okay, so as I said to you that the blood pressure is nothing but the force exerted by the flowing blood through the blood vessels, right? Whenever the blood is going to flow through the blood vessels, it is going to exert some force on the walls of the blood vessel, right? And that particular force is known as blood pressure, right? So let us see how we can determine the blood pressure. Okay, so uh, if you as if you know with how much force the heart is going to pump the blood out, because the blood is pumped by the heart itself, right? So if you know with how much force the blood is heart is going to pump the blood, okay, so then and you know the resistance offered by the vessels, then you can easily find the blood pressure, right? Then it will be bp is equal to co into pr. Okay, this is the resistance offered and this will be your volume. Okay, so I will if in the next class, if possible, I will try to have a problem in this. So then I will explain you detailedly about what will be the CO value and what will be the PR value. Okay. So but now just remember that the formula for blood pressure will be CO into PR. Okay. And then coming on to the cardiac cycle. Okay. As I had said to you that they will be the complete heart cycle can be divided into two different parts, right? One will be your systolic and other one will be your diastolic, right? So if you want to know the time, how much time it will take for systole and diastole, okay. So for the systole will take 0.3 seconds and the diastole is going to take 0.5 seconds, okay. So if you want to know one heartbeat, the time taken for one heartbeat or for one cycle of cardiac cycle, so it will be your 0.8 seconds, okay. So you have to remember this. You may have the questions whenever you are going to do the lab, okay. So what is the cardiac cycle? The cardiac cycle is going to have two phases, right? One will be systole and other one is diastole. So if you want to know the systole, so what the systole time takes, the systole will take 0.3 seconds, and whenever you are discussing about the diastole, so the diastole is going to take zero point 0.5 seconds. So overall, the one cardiac cycle will take zero point 0.8 seconds. Okay. So I think it's right because normally it is at the 72 beats per minute. Then it is 0.1 beat is going to take 0.8 seconds. Then uh, approximately it will be 72 beats. Okay. So let us now discuss the automatic blood pressure measurement, or you may call it as an digital sphygmomanometer. Right. In the previous class, I had explained you how the analog sphygmomanometer is going to work, and I had explained you how the doctor uses to measure the blood pressure by using analog manometer, right? So now today let us discuss how the distal sphygmomanometer, or you may call it as an automatic blood pressure measuring apparatus. Okay, so I had given a broad name for this, but in the market it will be called as a distal sphygmomanometer, right? So how it is going to work? It is also going to use the same Korsakoff sound. Okay, Korsakoff's method. So it is also going to wait for the sound, and it is going to take the systole and diastole. But how it is going to take? So let us see how the digital sphygmomanometer is going to measure the blood pressure. Okay, so let us see. So what we are going to do in the digital sphygmometer, we are going to place a curve, right? So we are going to place a curve on the upper part of the patient's limb, okay, or arm, okay. And then, as in the previous analog type, there we are going to place a stethoscope, right? We are going to listen for the Korsakoff sound by using the stethoscope, right? Here in the automatic sphygmomanometer, the stethoscope will get replaced by a microphone, okay? And their manometer filled with mercury is going to represent the pressure, okay? Here it will get replaced by an pressure sensor, okay? So what happens? And there the doctor used to press a bulb, and by whenever you're going to press the bulb, the pressure is going to get inflated, right? But what happens here? Here there will be a pump. Okay, so here completely you are replacing the stethoscope with a microphone. You are replacing the manometer with an the mercury manometer with an pressure sensor, and you are replacing the bulb with an automatic pump. Okay, and all these the pressure sensor, okay, the pressure sensor, the microphone, and the pump, all this will be connected to an microcontroller, okay. And this particular microcontroller is going to collect the data and view the signal to the pump, or everything will be done by this microcontroller, okay. So now let us see, okay. So what will happen? So normally what will happen, whenever you click on the start button, okay, there will be a start button on the digital sphygmomanometer, okay. So don't go to the text, just listen my what I'm going to say. Whenever I will do the PPT, then you can go to the step, okay. Don't read whatever there is on the screen, okay. So what I am going saying here, just go listen that, okay. And what I am going to draw on the slide, just see that, okay. So what happens? So this is your sphygmomanometer, okay, and there will be a start button on the this is sphygmomanometer, okay. Whenever you click on the start button, okay, so the pump will get started, okay. There will be a air pump inside your sphygmomanometer. The pump will get started, and it will start inflating your cuff, okay. It is going to pump the air into your cuff, okay. And at what rate it is going to pump the air? So it is going to pump the air at a rate of 300 mm of Hg per second, okay. So it is going to fill 300 mm of Hg pressure for a second. I like this. Yeah, I think it will take approximately 6 seconds. Okay. Or when till 6 seconds, it is going to inflate a pressure of 180 mm of Hg, right? Because it is going to inflate 30 mm of Hg per second. So when you are going to reach the 6 seconds, so till 6 seconds, it is going to inflate 180 mm of Hg pressure on the cup. Okay. So 180 is greater than systole or not? Right? It is going to be greater than systole. Okay. So it stops the pump. Whenever it operates for the 5 seconds, it may be 150 or 180, okay. Whenever the pumps operate for the 5 seconds or 6 seconds, after that the microcontroller will give a command to the pump to get turned off, okay. So here you are having a pump, this will give a signal to that pump to get turned off, okay. Once the pump will get turned off, okay, now the controller starts reading the values from the pressure sensor and from the microphone, okay. So now the task of the microcontroller, which is inside your digital manometer, is to read the values. Okay, it is going to read the values both from the pressure sensor and from the microphone. Okay, because doctor also uses to do same, right? He is going to inflate it about the systolic pressure. So there the job is done by your pump. Okay, and now what the doctors do next? He is going to deflate, and he is going to observe for the sound and manometer. He is going to hear from the sound, and he is going to observe the pressure. Okay, so the hearing is one of the sense of the doctor, and observing is also one of the sense of the doctor. So here we are replacing both with a sensor because it is an automatic system. So here the hearing job, which is a natural sensor for the doctor, is replaced by an artificial sensor, which is called as uh, microphone, and the vision, the seeing of the doctor, because it is a natural thing for the doctor, but here it has been replaced by an artificial sensor, that is your pressure sensor. Okay, so now what happens? Now the pump starts deflating. Okay, not the pump, there will be a valve there, pressure valve. So now the pressure valve will start deflating because the pump had inflated the curve up to 150 or 180 mm of HC, right? So now the pressure valve will start deflating the pump. Okay, it starts deflating at a rate of 3 to 5 mm of HC. Okay, that means for 1 second it is going to decrease 3 to 5 mm. Like it is going to decrease the pressure slightly because we can inflate the curve at a high rate, but we can't deflate the curve at a high rate because if we deflate the curve at a fast rate, because we are inflated it at the speed of 30 mm of HC, right? But here we are reducing it at a 1 by 10th speed. The reason why we are reducing it at a speed of 1 by 10th is because we have to observe the Kotakov sound very carefully, right? We have to observe the Kotakov. If you are reducing it at a fast rate, then there is a chance that you may miss the Kotakov sound. Okay, so for more accuracy, so we will inflate it with a rate of 30 mm of Hz, but we are going to deflate it at a low rate because the speed will be less. So we are going to deflate it at a speed of 3 to 5 mm of Hz per second. For every 1 second, the pressure will be deflated at a rate of 3 to 5 mm of Hz. Okay. So it will start deflating, and this sensor is going to here for the photocop sound, and this sensor will display the pressure on your display. Okay, it is going to measure the pressure on the cup, and it is going to display it on, yeah, on the display, LCD or LED, whatever display you are having on the equipment, it is going to display that. Okay, there is no use of any pump here. Okay, now it will listen for the sound, and it will display the reading. It will display the pressure value continuously on the display. Okay, once here, what you are having here, you are having a microphone, right? Once if the microphone listens, or if it gets an uh, what you can say, protocol sound. So what it will do, it will initially give a signal to the microcontroller that record the pressure. What it will do, it will immediately give a signal to the microcontroller that record the corresponding pressure. So what will do, as the pressure is continuously getting displayed on the display, okay. So whenever the microcontroller gives a signal that I had here the cutoff of sound, so whatever the pressure it is getting from the pressure sensor, it will store that pressure in the memory. Whatever memory it is having, it will store the pressure in the memory. Okay, and that it will store that pressure as a with a name of systole. Okay, and then the cutoff of sound will continue. So the microcontroller continuously get the signal, continuously get the signal. At one particular point, what happens? The cutoff of sound will get shut down, right? Because I had already explained you that whenever the vessel just opens, because of the turbulence, there will be a sound, right? And that sound is known as Kotakov sound. So that means here that sound, the pressure related to that sound will be your systole, and once your blood vessel opens completely, the sound will get seized. And whenever the sound will get seized, the corresponding pressure will be your diastole, right? The same thing is happening here. Okay, whenever the sound ceases, so again the microcontroller gives a again the microphone will give a signal to the microcontroller that I am not able to hear the sound. So what will the controller do? The controller will immediately store the reading at the time, whatever the reading it is getting from the sensor, pressure sensor. It will store the pressure with the name of diastole. Okay, and after that it will display both the systole and diastole reading on your display. Okay, so this is how the okay, so this is how the digital signal manometer is going to work. But okay, if it is getting the signal from the microphone, or it is getting the signal from the pulse sensor, the first thing that it will do is the controller will amplify it, and then the controller will filter it. Okay, and the band pass it, and the filter that you are going to use in the uh, digital signal manometer will be your band pass filter. Okay, and the band pass cutoff frequencies will be 25 and 125 hertz. Okay, so because I had selected this frequency, because at this particular band pass band you are going to get a good signal to noise ratio. Okay, so those who are not able to understand what is band pass filter and what is signal to the noise ratio, I will explain you. Okay, just wait for 2 minutes. I will explain you what is the band pass filter here. Okay, and after this topic, blood pressure, I will discuss the transducers and sensors. There also, I will again explain you the different filters that you are going to have here. Okay, so who knows that it is good? Those who know, I will explain you, because there are 2 to 3 mechanical people. They may know. I am not saying that they don't know, but they may know or may not know. Okay, so what happens? Whatever the signal that is getting from the sensor, it may be the microphone signal or it may be the pressure signal. So before the controller reads the signal and displays the pressure value on the display, there is something happening between that. What happens? It will amplify the signal, and then it will pass it into the band pass filter, and band pass filter will have a cutoff frequency of 25 to 120 Hz. The reason why the band pass is having the cutoff frequency of 25 to 125 Hz, at this the signal to noise ratio will be good. Whenever the signal to noise ratio will be good means you are going to get more signal and less noise in your output, right? That is the reason why I have done this. Okay. So this is how your digital signal mathematics is going to work. Okay. I will again summarize this. Okay. So have you understood? I will summarize it again at the ending of the topic. So have you understood how the digital signal management is going to work? If you have any doubt, you can ask. Have you understood? If you have any doubt, you can ask, or otherwise you can move into the other part of the lecture. तो कोई तो बोलो, समझ में आया नहीं?
आ गया सर।
ठीक ठीक ठीक। Okay. So this is how your digital signal manometer will look like. Okay. If you come to the college, I will show you with this in the lab. Okay, we have in the lab. So this is how your digital signal manometer will go into. You can see here. This is the systolic pressure. This is the diastolic pressure, and this is the heartbeat. So it will display like this. Here, this is a start button which I had said that you will in the digital signal you have to just click on that. Whatever the other thing it will do on its own. Okay. So this is your signal manometer. Okay. So I will again repeat the operation of at the end of the class. Okay. So now let us see what are the variations. What are the factors that affect the variations? Okay. The first factor will be a physiological factor, and then your pathological factors. And also these are we cannot avoid this because these are physiological and pathological factors are related to the human subject, and we cannot avoid it. We can just reduce it, right? And then let us come into this one. Okay, the gravity. So you may think that what is the role of gravity in the blood pressure, right? So definitely the gravity is going to have some interference on your blood pressure values. Okay. So how it is going to have some interference. Okay. So how we are going to measure the blood pressure? Are you measuring properly, or if you are measuring above the heart level, or if you are measuring below the heart level? That will affect your reading, because if you measure the blood pressure, that means if you have placed the cuff on your arm and then your arm is above that means you have lifted your arm and then you have measured the blood pressure. So the BP, the blood pressure will increase. If you are going to measure below the heart level, it may decrease. And this happens because of the gravitational effect of your earth. Okay, it will happen because of your gravitational effect. Okay, so I will explain you and how we can correct it. I will explain you later. Okay, so just remember that the gravity is also going to play some role in your blood pressure reading. So normally that's the reason why if you observe, the doctor will make you sit down and then he will measure he will to measure the blood pressure only at the level of heart. Whenever you sit properly in a chair, and if you keep the hand on a table, then the position of the cuff will be equal to your heart level. Okay, then there is no need for doing any corrections in the reading. That's the reason why whenever they are going to measure the blood pressure, they use it. If the patient is laying also, they use it to make him sit, and then they are using to measure the blood pressure. Because if you make because if you measure it above the heart level or below the heart level, then it may have some error, and you have to use the correction factor. I will explain you the correction factor now. Okay, okay. So what is hypertension? Okay, so hypertension is nothing but the increase in the systematic arterial pressure. Okay, if a BP is above a certain normal limit, then you can call it as a hypertension. Okay, so let us see the limits of the blood pressure. Okay, so normal. Okay, normal limit of the blood pressure is 120 by 80 mm of Hg. Okay, this is called as ideal blood pressure. Okay, and if you are having the systolic blood pressure between 120 to 139 and diastolic blood pressure between 18 to 90, so it is known as pre-hypertension state. Okay, don't get afraid. It is not any problem in you. And pre-hypertension state may happen. This may occur because of not taking meal at right time, or if taking or having smoking. So all this causes this, and this is not that much dangerous state. Okay, pre-hypertension is not a dangerous state. And if you have anxiety, then also your blood pressure may come in this range, 120 to 139 and 80 to 90. Okay, so these two are considered as a, not dangerous values. Okay, now you have to consider the remaining two here. Okay, so the stage 2 and stage 3 of hypertension. Okay, so if you are having, whenever if you measure your blood pressure and if your blood pressure range is between 140 to 159, your systolic, that is upper limit, is having a pressure of 140 to 159, and your diastolic is having a limit of 90 to 99. Okay, then you can call it as a stage 1 of hypertension. Okay, then you have to worry that I have having some problem with you. Okay, so it is considered as a stage 1 of your hypertension. And if you go into the stage 2, if you are having a systolic pressure greater than 160 and diastolic pressure greater than 100, then what's happened? So stage 2 hypertension. Okay, if your systolic pressure is greater than 160 and your diastolic pressure is greater than 100, then it is a concerning issue because it is a stage 2 of hypertension and it may cause an heart stroke or heart failure in a human being. Okay, so try to remember these readings. Okay, if you are going to do the lab, then in the lab you may ask that what are the ranges. Okay, if you are having 125 or 80, then it will be, you can consider as an ideal human being, that then you are not going to get this value. So if you are getting normal or pre-hypertension, then you are healthy. Okay, if you are getting the values with stage 1 hypertension or stage 2 hypertension, then they need some problem with you and you have to consult a doctor, right? So now come out to hypotension. Okay, so hypotension is also another stage of one of the disease where your blood pressure will be below the normal level. That means you are going to get the blood pressure below 120 by 80. Okay, it is also very dangerous for the human being because if this mechanism will occur whenever your body will get cooled. Okay, if your body will get too cooled, then you may go into the hypotension state. Okay, because the pumping of the blood, the heart operation will become low. The how many beats that the heart is going to do per minute will get reduced, and this then your complete body will get very cold. Okay, so this stage occur whenever your body will get very cold. Okay, so this is no condition of hypotension, and normally hypertension happens very rarely, and most of the time the hypertension will get happen. So try to remember all these four different stages. Okay, and now let us come into the sources of error. So what are the errors? What are the various sources of error that we may get in the blood pressure? Okay, the first line is you may get the error because of the manometer. Because if you are using an analog sphygmomanometer, so you have to observe the mercury level, and the mercury level is going to observe by the human being, right? Take 1 minute. 1 minute, 1 minute. Just wait for 1 minute, okay? Okay, sorry for the interference. So am I audible now?
Yes, sir.
Okay, okay. So let us continue our topic. Okay. So 1 minute, I will share the screen. Okay. So we are here, right? So what we are going to discuss here is we have some errors. Okay. There may be some chances of error in your manometer reading. Okay. That means if you are measuring the blood pressure, so there may be a chances of error in your reading, and the sources of the chances may be your the first source of error will be your manometer. Okay, because if you are measuring the blood pressure using a analog type sphygmomanometer, so the first thing, the first error that you are going to use, because there you are going to observe the mercury level. So so what happens? It is a human error, okay, because you are going to observe a mercury level, so there may be some human error in observing, okay. So the first one is related to a manometer, and the second one will be related to a cuff, okay, because you are going to place a cuff on your arm, right, on the patient's arm, okay. So what happens? So depending upon the patient, you have to choose your cuff size, okay. So the cup size may be different. They may be for adult, and then for large adult or for children. So depending upon the size of the arm, because some of the person may have because if you take any fatty patient, so he may the size of your each arm will be uh, big, so the cuff will not adjust properly. Because okay, so the placing of the cuff may also have may bring some errors in your reading. Okay, and then errors due to your observer, okay, and it is your observing error, and then it is due to the patient, okay. So whenever you place the cuff on the patient's arm, if the patient uses to move his arm, or you may do like that, then there may be some error, chances of error in your blood BP reading, okay. So these are the various sources of error, okay. And then coming on to the cuff sizes, okay. So these are the cuff sizes, okay, for the adult. If you are doing the um, blood pressure measurement for the adult human being, okay, so you may choose a cuff size of 12 centimeter by 23 centimeters if the adult's arm is small, okay, if the arm is smaller arm, okay. And then you may also use the alternate cuff, which is going to have a size of 12 centimeters by 36 centimeters, okay, and it is suitable for covering 95% of arms, okay. So normally 95% of human beings arm you can cover it by using this 112 centimeter by 36 centimeters, okay. And other one is there which is of large adults, that will be 15 centimeters by 36 centimeters, okay. So this will be for fatty arm, okay. If it is, if someone's arm is too wide, okay, then for them you can prefer these cuff sizes, okay. These are the different cuff sizes that you are going to have, okay. So normally in most of the cases, this second one you can see here, 12 centimeters by 36 centimeters. Normally, this one will be used by most of the adults. Okay, but okay, if the person is too fatty, then you may prefer this one, 15 centimeters by 36 centimeters. Okay, so these are the different cup sizes. Okay, so now let us uh, see that I had already said you that if you are not going to take the blood pressure at the heart level, if you are going above the heart level or if you are measuring below the heart level, then you have to add some correction factor to get the exact reading. You may add or you may have to minus the correction, right? As you do in your instruments also. So what you have to do, you may add some correction, you may have to remove some correction. Okay. So whenever if you are going to, okay, if you are going to measure the uh, if you are going to measure the blood pressure, okay, if you are going to measure the blood pressure above the heart level. Okay, so let us consider you had measured placed your arm at a height of HMM above the heart level, or let us consider you have placed your arm HMM below your heart level. Okay, so what happens? The way of the column HMM, the HMM will cause your errors. Okay, so how we are going to calculate this? Because normally in an analog sphygmomanometer, you are going to have mercury there, right? So you have to take the density of your mercury, that is 13.6 gram per centimeter, and you have to take the density of your blood, that is 1.055 gram per centimeter cube. Okay, centimeter cube. Okay, so this will be also centimeter cube. Okay, so now the ratio will be the mercury to the blood. This will be 12.9. Okay, you have to remember this constant. How we had get this constant? We had get this constant by taking the ratio of the both the densities of the mercury and the blood. Okay, and then now uh, what you have to do now, we have to calculate the reading. That will be above or below the heart level by 12.9. Like, let us consider if you have measured the blood below your heart level, like you have, the person has been bended and you have placed the cuff on them and it is below your heart level. Okay, the position of the cuff is below your heart level. That means the arm is below your heart level, so the position of the cuff is below the heart level. Then you have to measure how much height it is below the heart level. Okay, and that height should be divided by 12.9. Okay, you have to measure the height, how much height the arm is below the heart level. Okay, that will be height, and you have to take the height in mm, and you have to divide that height will be 12.9. Okay, and this will be your correction factor. Now after that, when you measure the reading, reading, so you are going to get the systolic and diastolic pressure, right? So you will add or subtract this reading. Okay, if you done this reading above the heart level, then you add this factor to the systolic and diastolic pressure value, and if you done the reading below the heart level, then you are going to subtract this value from systole and diastole. Okay, have you understood? So one, this 12.9 has been taken by having the ratio of below the blood and the mercury, because the error is happened because of some gravitational force occurring on the blood when you place it up above the heart level because of the gravitational force, or if you placing below the heart level because of the gravitational force, right? So the you are going to take the ratio of both the mercury and the blood, and then let us consider I had measured below the heart level, then how much below I had measured the height in mm and divide the height with 12.9. That will be your correction factor. And now whatever the final reading you are going to get, try to, if you are measured below the heart level, try to minus them, uh, try to minus the value, the correction factor from systole and diastole. If you measure above the heart level, then try to measure how much height you have measured and divide that with 12.9. That will be your correction factor, and then add this correction factor to systole and diastole reading that you have measured. Okay, so this is how we are going to have the correction factor. Have you understood how this correction factor has been taken? समझ में आया? अरे समझ में आया? कोई तो बोलो.
हाँ सर समझ में आया.
Okay, okay. So till now you have completed your indirect measurement of blood pressure. Okay, this is complete the part of indirect method of measuring the blood pressure. Okay, in the indirect method of measuring the blood pressure, you are having two meters. One will be your analog sphygmomanometer and one will be your distal sphygmomanometer. Okay, in the I had explained you how the analog sphygmomanometer is working and how the distal sphygmomanometer is working, and then I had explained you the various cuff sizes and the sources of errors, and then I will explain you how the correction factor will be taken if you have measured the reading above the heart level or below the heart level. Okay, this correction factor will be same for both the distal and analog. If you measure for the distal also, you will measure the height and divide it with 12.9, and then this correction factor will be added or minus depending upon that if you measured above the heart level or below the heart level. Okay, so this will be same for both analog and distal type. Okay, so now let us move into the other part of your 1 minute. Okay, so are you able to see the slide here?
Yes, sir.
Okay, so now let us discuss the other part of your blood pressure monitoring. Okay, this is direct method of blood pressure monitoring. So I will just briefly explain you in the 3 slides. Okay, so how the direct method of blood pressure monitoring will be done. Okay, so I had already explained at the starting of the unit that in the direct method of blood pressure monitoring, we are going to puncture the arterial blood vessel, and then we are going to insert a probe into the blood vessel. And that probe is going to have a sensor, and that sensor is going to measure the blood pressure, right? So the phenomenon will be same. This is what happening in the direct method of monitoring blood pressure. Okay, you will puncture the blood vessel, you will insert the probe inside the blood vessel, and there will be a sensor is going to measure the blood pressure. That means the probe will be the important thing here. Okay. So let us discuss the probe part. Okay. So when in the direct method of blood pressure monitoring, the probe may be of two different types. Okay. One will be your catheter tip probe, and other one will be your fluid filled catheter type. Okay. So these are the two different probes because we have to know this probe. Other thing will be common. Puncture a vessel and insert the probe inside it and then see the blood vessel reading. Okay. So you have to know what the probe, what are the different types of probe that you are going to have. Okay. The first type will be your catheter tip probe and the second type will be your fluid filled catheter type. Okay. So let us see what happens in the catheter tip probe. Okay. So in the catheter tip probe, okay. So you are going to have an it is a catheter toe probe and you are going to have an sensor at the tip of the what the end of the probe. Okay, at the tip of the probe. Okay. So whenever you puncture the blood vessel and insert the probe inside the blood vessel, the sensor which is at the top of the probe or which is that will go inside your blood vessel and that probe will measure because the blood will flow through the sensor. Okay. So the sensor will directly convert the pressure in the blood into electrical signal and this electrical signal will be displayed on your display. Okay. So this is how your catheter tip probe is going to work. Okay. And then coming on to the second type, fluid filled catheter type. So in this what happens, the catheter is going to be filled with a specific fluid. Okay. So what happens whenever the catheter goes inside the blood vessel, so the flowing blood will produce some pressure on the fluid. Okay. And that pressure will get transferred through the fluid and at the top, but outside the blood vessel, there will be a transducer. What the transducer will do, what are the force that is exerting on the fluid, the transducer will convert that exerted pressure into an electric signal and you are going to amplify this signal and going to display this signal on a display or you may record this signal. Okay. So this is how the both the two types of catheter probes are going to work. Okay, so I am repeating that in the catheter tip probe. Okay, so you are going to have a sensor at the tip of the probe. Okay, so whenever you are going to puncture the blood vessel and whenever you are inserting the probe into the blood vessel, so the sensor will come in contact with the blood. So whenever the blood flows, the sensor will convert the pressure of the blood into the electric signal, and this electric signal will be amplified, filtered, and then amplified and filtering will be common in everything. Okay, this signal will be amplified, filtered, and then it will be displayed or it may be recorded. Okay. So there the sensor will directly convert the blood pressure. Okay. But what happens in the fluid field type? In the fluid field type, whenever the probe get inserted into the blood vessel, so the force exerted by the blood will be exerted on the fluid. Okay. And the fluid is going to transmit the force to a transducer externally and this transducer is going to convert the force into the electric signal and then this electric signal will be converted into amplified and amplified filtered and then it will be displayed or recorded on a display system. Okay. So among these we are having two types, right? One will be catheter tip probe and other one will be fluid filled. So among both of them, which is more advantageous? So the catheter tip probe will be more advantageous because it can record the dynamic values because the sensor is directly converting the blood pressure into an electric signal, right? So if there any dynamic changes in the blood pressure, so it will be easily measured by this catheter tip probe. But if you come into the fluid filled type catheter type, so it is not going to work that much dynamically. That means it is not going to give immediate change because of fluid. The fluid is going to have some fluid friction, and because of that, it is not going to be that much suitable for a dynamic. Okay. And the other thing that you have to remember whenever you are going to use a fluid fill system is you have to flush it properly before flush the fluid properly before inserting the probe into the blood vessel. Okay. And normally sterile saline is passed through the catheter to prevent blood clotting in that. Okay. So this is how your system is going to work. Okay. So I had explained complete blood pressure, right? So do you have any doubts?
No, sir.
Okay, so I am summarizing complete topic. Okay, the blood pressure measurement can be divided into two types. One will be your direct measurement and other one will be your indirect measurement. Okay, so in the direct measurement, you may have two different devices. One will be your digital sphygmomanometer, other one will be your analog sphygmomanometer. Okay, so in the analog sphygmomanometer, you are going to have a mercury filled manometer and the doctor will place a cuff on the arm and he will inflate it by using a bulb and he inflate it still above the systolic pressure and then he will slowly deflate it. He will place a stethoscope below the cuff and he will observe whenever you are decreasing, he will try to listen for the cutoff sounds through the stethoscope and also he will observe the pressure. Whenever he starts listening the Kotokoff sound, he will mark that pressure as the systole, and whenever he stops listening the Kotokoff sound, he will mark it as the diastolic pressure, and he will say that your blood pressure is normal, whatever it is. Okay. And what happens in the digital side, the stethoscope will be get replaced by an microphone, and the mercury manometer will get replaced by an pressure sensor, and the bulb which the doctor is pressing will get replaced by an pump. Okay, so what happens whenever you click on the start button? The pump will start inflating, and it will inflate at a rate of 30 per second. That means in 6 seconds or 5 seconds, it is going to inflate the cuff above the systole pressure, and then it starts deflating. It deflates at a rate of 3 or 5 per hg, and there the microphone will try to listen for the Kotokoff sound, and the pressure sensor will display the pressure continuously on the display. Whenever the microphone listens the Kotokoff sound, it will give the signal to the controller, and the controller will store the pressure value where whatever it is getting in the pressure sensor as a systole, and then the sensor will continue to read the here for the sound, here for the sound, and whenever the sound gets ceased, again the controller will record the corresponding pressure that it is getting from the pressure sensor as a diastole, and it will display diastole and diastolic pressure on your display. Okay, so this is how your digital signal is working. Digital signal manometer is working. Okay, and then I had explained you the different normal level, stage 1 hypotension, stage 2 hypotension. Okay, hypertension, and then I had explained you the sources of errors, and then I had explained you the different cup sizes. Okay, so whatever important, I am repeating that, and whatever you have to know generally, I am just naming the topics. Okay, and then I had explained you the correction factor, because if you measure above the heart level and below the heart level, there may be some errors in the blood pressure reading because of the gravity. So if you measure the blood pressure above the heart level, try to measure how much height above you are measured, and divide that with an 12.8, and the 12.8 has been get from the ratio of density of blood and of mercury, and just you have to measure how much height you are placed the arm above the heart, and that height will be divided by 12.8, and then this will be your correction factor. So what you will do, if it is above, the height is above the heart level, you will add it. If it's below heart level, it will minus it. Okay, and then I had explained you the digital direct method. In the direct method, you are going to have the, in the direct method, in the indirect method also the working is same. Just the physical parts are getting replaced by the sensor, and in the direct method also the working is same. Puncture a vessel and insert the probe. But here you are having two probes. One will be your catheter field, and other one will be your fluid field. Okay, in the catheter type, sorry, in the catheter tip type, you are going to have a sensor at the tip of the catheter. Whenever you insert the probe into a blood vessel, the sensor which is at the tip will measure the blood pressure, and it will convert it into electrical signal, and this signal will be amplified, filtered, and then displayed or recorded. And what happens in the fluid field type? In the fluid field type, whenever the probe gets inserted into the blood vessel, the pressure exerted by the blood will be exerted on the fluid, and the fluid will transmit the pressure externally, and externally there will be a transducer which will convert this fluid into electric signal, and again this electric signal will be amplified, filtered, and then it will be displayed or recorded. Okay, so among these, which is more advantageous? The catheter tip, because here the sensor is directly converting the reading, because the sensor is in direct contact with the blood, and it is directly converting the reading, so it can easily measure the dynamic changes in the blood pressure. But the fluid field may not measure dynamic changes as fast as this catheter tip type, because it is having the fluid friction here. Okay, and if you are asked that among the direct method and indirect method, which is more advantageous, the direct method is more advantageous, and the reason why the direct method is more advantageous here is the reading that it is going to measure will be accurate, because it is directly measuring from the blood. And other advantage that it is having is, here you can get the continuous reading. Okay, you may get for 24 hours, 48 hours. And what is the advantage that indirect method is having? It is easy to measure, because there is no need to puncture the blood vessel, so it is easy to measure. Okay, and it is used for initial screening. Okay, if you want to measure the blood pressure only for one time, then everyone will prefer the indirect method. That means the digital or analog sphygmomanometer. If you want to measure continuously, then they will prefer catheter type or fluid field type probes. Okay, so this is about your complete blood pressure VBT. Okay, so if you are having any doubts, you may ask. Okay, किसी को डाउट है तो पूछ सकते हैं.